Hello students. So today will be the day 7 of this JEE 40 days crash course, and today we will cover the chapter chemical thermodynamics. So join the class as soon as possible. We will begin our class by 4 or 5. If you have a doubt, anything related to chemistry or our website, you can just post it here. We will try to resolve it as soon as possible. So we'll start a new chapter today in our this series of this 40 days crash course, which is thermodynamics, and today we'll cover up to the enthalpy part. Got it? Then after today, that means tomorrow, we will move on to this Gibbs free energy, then our spontaneity and all. Yes, this class is absolutely live. Please join the class. We will begin it at 4:05. Anyone who has a doubt related to chemistry or related to our website, you can just comment it here. We will try to solve it. So do you have a suggestion for this class which is going on right now for this 40 days crash course? Something which we can do to improve our class? You can just post the suggestions here as well. So basically, if I talk about the melting point of neopentane, so in case of melting point, the part that plays an important role is your symmetry. Okay, so neopentane is something which is more symmetric as compared to that of the N-pentane, and as a result of that, we see that the neopentane has higher melting point. So this is just the opposite which is seen in the case of boiling point. In boiling point, all of this depends upon the branching, but here it also depends upon the symmetry of the molecule. So please join the class as soon as possible. We'll start our class in few minutes. If you have a doubt regarding our session, or if you have a suggestion regarding our session, you can just comment it here. We will try to implement the same. Or still, if you are facing any problem which is related to a specific question, you can just post that on our SATHEE forum. Or still, if you are facing the problem, you can just join our doubt session, which starts from 10 at the morning and goes to 6 at the evening. So this will be our first day of chemical thermodynamics. Please join the class and please comment it down that we can start our class. So we'll cover up to the enthalpy part today, and then after, in the tomorrow's class, we will move on to the rest of the topics, which includes the Gibbs free energy and the spontaneity. Okay, so we shall start now. So this is our disclaimer. Now, if I talk about the analysis of this chapter, chemical thermodynamics, then it is having a weightage of 3.7%, and at least one question is included for each year from this chapter. Whether you talk about 2017, 2018, or you move through this whole year to 2024, this frequency is seen in each and every year. After that, let us see that what are the important topics. So This chapter is totally based on formulas. Got it? And most of the questions are formula based rather than the theory part. Therefore, I will encourage you to solve as much as problem possible in this chapter. So here you can see that questions are asked from each and every part of the chapter. If you talk about first law, you talk about inotropy, or you talk about the second law. So this is something which is to be learned as a whole. Then we can again see questions from spontaneity gives free energy. And if I just specify the most important part in this, then it comes from your spontaneity and gives free energy part, right? So the most important topic regarding this chapter is your spontaneity gives energy change. Got it? Now, if I talk about the topic's name, so first we will look upon the fundamentals in a quick manner. Then we will move upon extensive and intensive property, state and path function, then types of processes, right? Then we will look upon work, heat, internal energy, that is represented by E and U. And lastly, we have first law of thermodynamics and then after enthalpy. So our today's focus is mainly upon the first law of thermodynamics, and our discussions will be around that topic only. First, we will talk about the fundamentals. The laws of thermodynamics deal with energy changes that occur in a macroscopic system, which involves a large number of molecules rather than a microscopic system. This is a very important fact that thermodynamics is based on macroscopic systems and not on microscopic ones. Boiling point, melting point, all these things also depends on a large number of molecules. We never observe the boiling point of a single molecule. We always have to consider a group of molecule or a large number collectively. Density, pressure, volume, temperature, etc. All these are also macroscopic properties. In a microscopic system, there are only a few molecules. Now, we will look at the system surrounding an universe. First of all, let us see what a system is. The thing on which the work is done or which is being studied is called a system. System is that part of our total universe which we are observing or considering. Second is surrounding. So whatever is left in the whole universe apart from the system, it is considered as our surrounding. Lastly, we have the universe. So the system and surrounding adds up to give us the total universe. Got it? So this is the starting point of our thermodynamics. What are the things that you should remember? First thing, that your thermodynamics is related to the macroscopic system and not to the microscopic system. Then what is system? System is the part of the universe where we are considering or where we are observing the change. All other part other than your system is considered as surrounding, and if you add up the system and the surrounding, you will get your universe. Then we have types of system. So based on the exchange of mass and energy, we can categorize system into three types. What are those types? The first one is the open system. It is clear from the name itself that it is completely open. This means both mass and energy can be exchanged here. That is, systems in which both energy and matter can be exchanged with the surrounding are known as open system. Take a simple example. If there is a tea in a cup, then water vapors are escaping from it. So this is an open system. The tea will cool down after some time, which means heat energy has been exchanged and vapors are also going up. So matter is also being exchanged. Then we have a closed system. If you cover the cup with something or cover it with a plate, then in such a system only energy can be exchanged, not matter. This means it is a closed system because it is properly packed. So in an open system, both energy and matter can be exchanged with the surrounding, and in a closed system only energy can be exchanged and not the matter. Lastly, we have isolated system where neither energy nor matter can be exchanged with the surroundings. We call this an isolated system. If we take an isolated system, meaning no heat goes out like a thermos flask, ideally, no thermos flask is such that once a temperature is set, it remains maintained forever. No, it has also some limits, such as 24 hours or 35 hours or 48 hours or 12 hours, whatever the limit may be, but a perfectly isolated system is not possible. Now, if it is possible, then we will consider only those systems which cannot exchange matter as well as energy at the same time. Now, moving on to the next thing, which is properties. So, properties are something which is used to define the state of a system. The properties that are used to define the state of the system are classified as extensive and intensive properties. Now we will talk about intensive properties. So these are properties that do not depend on the quantity of matter but depend on the nature of matter. For example, pressure. Temperature is also an intensive property. If you take a container and divide it into two parts, the pressure and temperature will remain the same. For example, we can take specific heat also, melting point also. So all these are intensive properties. Then what are extensive properties? Extensive properties are those properties that depend on the quantity of matter. If we talk about the volume, volume depends upon the quantity. For instance, if there is a container with 400 ml of water, and if we divide it by placing a slab in the middle, then both sides have now 200 ml. So volume is changing. Therefore, it is an extensive property. We can take more examples like internal energy, heat, moles, enthalpy, entropy, and free energy. Remember, force is an extensive property because it depends upon the quantity of matter, and pressure is an intensive property because it does not depend on quantity of matter. How can you know? How is there a shortcut to it? So remember, whenever you divide two extensive properties, you always get an intensive property. Suppose I am defining pressure. So pressure is defined as force per unit area. Force is an extensive property as well as area is an extensive property. And when you divide two such properties which are extensive, you always get a intensive property. We can take the example of density also. So density is equals to mass per unit volume. Both mass and volume are extensive property. So the ratio of these two, mass and volume, will give you an intensive property, which is your density. Okay, so this is a very important point to remember. Next, we will study about the state and path functions. State functions are those functions which depends only on the initial and final state of the system. Now, you can look at it in two ways. Suppose you have to come to the 6th floor, and then you can come in two ways. Either you use the lift or you use the stair. But state function, being a state function, it does not depend on the path that you choose. It only depends upon the initial and final destination. You can take examples of it. We have pressure, then we have volume, then we have temperature, enthalpy, and internal energy. So these are some state functions. Then we have path function, which depends on the path. If one has to go from point A to point B, then the path which we have chosen is also deciding the exact value of the quantity. That in that case, we call it as a path function. The examples of path functions are work done and heat. So these are the only two examples of path functions. Yes. So this is the most important point. What are the examples of path functions? You can easily differentiate between them. Remember, work done and heat are the only path functions. Sometimes internal energy also acts as a path function, although it is a state function. Can we take any case for that? Suppose we are taking an adiabatic condition. What we are taking? We are taking an adiabatic condition. Adiabatic means no heat will be exchanged. In that case, the internal energy will be equals to the work done. And work done is already an path function. So your internal energy change will be also a path function. You get my point? So internal energy can also act as a path function, but in some special cases only, like an adiabatic process. Or suppose if you are taking the volume constant, then in that case the work done will be 0, and therefore your internal energy change will be equals to the heat change, and hence your internal energy change will be considered as a what? Path function. Is it clear to you? Okay. Now moving forward, next we have types of processes. So the state of a variable can be changed through thermodynamic processes. These processes are of several types. First is adiabatic process. Adiabatic here means heat is constant, meaning a system in which heat exchange does not occur. An adiabatic process is one in which the system does not exchange heat with its surrounding. We can write it mathematically as dq is equals to 0. Then we have isothermal process in which temperature remains constant, that is delta T is equals to 0 or dt is equals to 0. Then we have isobaric process. So here we will keep the pressure constant. So we can write it mathematically as dP is equals to 0. After that, we can also have isochoric process where the volume change is kept at 0. So dV is equals to 0. Remember, not the volume but the volume change. Lastly, we have cyclic processes. So cyclic processes are those in which we have the same initial and final state of the system. In such processes, the value of all the path functions will be not equals to 0, whereas the value of all the state functions will be equals to 0. What did I say? Again, so in a cyclic process, the initial and final state are same. Since initial and final states are same, therefore the values of state functions change during that process will be taken as 0, because the change in state function depends upon the initial and final state, and since they are same, therefore their change is also 0. Okay, is it clear to you? Any doubt till this point? Remember, in cyclic process, the value of the state functions do not change, because in the case of cyclic process, the initial and final state are same. If you have a doubt, you can ask it here. So these are some fundamentals of thermodynamics which we are covering right now. I hope it is easy for you. Okay, so now we shall move forward. Next type of process is reversible process. Reversible means a process that can be reversed in any part of that state. In this process, the system is a quasi-static state, meaning the change occurs very slowly. Now, it is infinitely and slow and very slow. So what is your doubt? You can just ask it here if you have a doubt. This means the change is happening in such a way that you can reverse it at any point of time. The change that occurs in the steps of this process is infinitesimally small, and a reversible process is an ideal process which is not visible in our day-to-day life. So every process that you see around in your surroundings are all examples of irreversible process and not reversible process. So what is your doubt, Nandu? You can ask it here. Anyone who has a doubt? Okay, moving forward. Next is irreversible process. This is a process that cannot be reversed, and all natural process, as I said, which is seen in our surroundings, are irreversible process because it occurs in a unidirectional nature. For example, if you consider water, so water falling from a mountain is considered to be an irreversible process, because without any external agent or without any external factor, that water cannot be put back to the top. Okay, once it is once it has started to flow, and once it is has felt from the top to the bottom, it cannot be reversed by a small change. You have to constantly apply an external force to put that in the same state where it was initially. So that is the basic idea behind this irreversible process. Remember, if macroscopic systems like temperature, pressure, etc. do not change with time, the system is said to be in thermodynamic equilibrium. And if two systems are in thermal equilibrium with a third system, then there must be equilibrium between the two systems as well. So this is known as zeroth law of thermodynamics. Lastly, the law determines temperature as a property whether the body is in thermal equilibrium or not. So is reversible process and irreversible process clear to you? Do you have a doubt in this part? Okay, now we shall move forward. Next, we will study about work. When a gas expands or contracts against external pressure, then work is said to be done. Whenever gas undergoes compression or expansion against external pressure, then the work done is named as the pressure volume work. So this work is a path function, as we know, which means that the value of the work depends on which path is it followed between the initial and final state. It is not a state function because it depends upon the path. The formula you can see is written here. W is equals to minus P ext into delta V, where P ext is the external pressure that we are applying, and delta V is the volume change that is occurring due to this external pressure. If you consider it for the expansion process, then in that case your V2 is greater than V1 because the gas has expanded, the volume is increasing. Okay, got it? But if you consider it for the compression, then in that case your volume is decreasing. So V1 is greater than V2. If you calculate the value here, then for expansion the work done will be equals to a negative value. Okay, because we are seeing a negative sign against this P external. Overall V2 minus V1 is positive, and that thing multiplied by a negative gives you a negative value. So work is done in the case of expansion, and hence we are getting a negative value. And if we are doing work on the system, which is your compression, then in that case your work done will be positive. Next, the maximum work that occurs for a reversible isothermal process, then to calculate that we use the formula minus P external delta V, and we integrate it further to get it as minus nRT ln V2 by V1. Then you can replace your ln with 2.303 log to give you the final formula as minus 2.303 nRT log V2 by V1. So this is your formula to calculate the work done for reversible isothermal process. Here V2 and V1 are the final and initial volume. Also, moving on forward, if you are continuing with this work, now we will look at the irreversible isothermal expansion. In that case, when P external is less than the P gas, then expansion will occur. So this is the first case. So in that case, simply we will calculate work done irreversible as minus P external V2 minus V1. Then in second case, if we are doing a free expansion, that means you are taking zero external pressure. So P ext will be equals to 0. Hence, the work done will be equals to 0. What is the sign convention? So sign convention for work done is If work is done on the system, then W value comes out to be positive, and if work is done by the system, then W is taken as negative. So these are the two formulas of work done which you should remember. First one was for irreversible process, which is minus P ext V2 minus V1, and for your reversible process it is minus nRT ln V2 by V1 or minus 2.303 nRT log V2 by V1. Easy to get? Okay. Next, we'll study about heat. So we define heat as the amount of energy that flows between the system and the surrounding due to a temperature difference. As soon as a temperature difference occurs, heat starts flowing between the system from a body of higher temperature to a body of lower temperature until and unless there is a thermal equilibrium between those two substances, or you can also tell it as both substances have the same temperature. Remember, heat is also a path function and it depends on the path that has been followed. It does not depend, it does not only depend on the initial and final position, but also on the path which is being followed to transfer that heat. Let us now look upon to the sign convention. So if heat is supplied to the system, then Q is taken as positive, and if heat is given out by the system, then Q is taken as negative. Is it clear to you? Any doubt till this point? So if you have a doubt, you can just post it here in the comment section. So we have talked about all the types of processes. Then we are we have moved upon to work and heat. Now we will move on to the internal energy and the enthalpy. So if you have a doubt till this point, you can ask it here. Anyone who has a doubt in this part? Nandu, Disha, Dhruv. If you have a doubt, you can ask it here. Okay. So moving on further. Next, we will see internal energy, which is represented by E or U. If I just simply define internal energy, it is the total energy of the system. So each and every energy, whether the thermal or you consider the molecular energy due to vibrations of the molecule or your rotational energy, addition of all the energies within a system is named as the total energy as internal energy. So this thing is represented by E and U. Now, what are the types of energy that it includes? So as I said, it includes the transitional energy, the vibrational energy and the potential energy. So if you consider a gas, so the gas molecules are moving constantly. Due to it, it gets translational energy, and at the same time it has some sort of vibration during that movement. So that is equals to its vibrational energy, meaning that every energy that is being stored in a system is known as the internal energy. Got it? Now we can determine the change in internal energy by simply calculating the initial and final internal energy. So this is the most obvious path that we can take. First, what is the final internal energy minus what is the initial internal energy? If you just subtract it, you will get the change in internal energy. Why I am saying this? What is the reason behind it? Why are we not interested in the path of the system, but only on the initial and final state? Is there any reason for it? Why we are calculating the internal energy by just subtracting the final internal energy minus the initial internal energy? Is there any reason for it? What kind of function it is? Your internal energy, if it can be calculated using the final state internal energy minus the initial state internal energy. Any idea about this? Again, I'm repeating my question. So now I'm seeing a formula of calculating the internal energy change by simply subtracting the final internal energy minus the initial internal energy. We are not interested in the path, but only in the final and initial state. If it is the case, then what kind of function is your internal energy? Is it a state function or a path function? You got my question? So, anyone who is willing to give the answer? Yes, it is a state function because it depends upon the final and initial state only. Now, at constant temperature, the value of internal energy change is equals to 0. So remember, this is a very important line because it can help you to calculate internal energy change for many processes. Also, one very important point is to be known here that at constant temperature, the value of internal energy is not 0, but the change of internal energy is 0. Suppose you are doing a process, suppose you are keeping a liquid inside a thermos flask. Okay, now some work must be going inside the system due to the change of liquid water into vapor state and vapor back to the liquid. Got it? So that may be the case, but you are keeping the whole system inside a thermos flask. So in that case, your temperature is maintained at the same point and hence your internal energy will not change. But remember students, the value of internal energy will not be 0, but the change in internal energy is taken as 0. Okay. Then internal energy depends upon temperature, pressure, volume and quantity of matter. Now if it is depending upon the quantity of matter, whether it is an extensive property or the intensive property, what will be your answer? What kind of function it is? It is an extensive or is it an intensive property? Anyone who knows this answer? So we talked about two very important things here. First, internal energy is a state function. Second, it is 0 if the temperature is not changing, means the change in internal energy is 0 if the temperature is kept constant. Third thing which I am asking is whether it is an extensive property or an intensive property. So is your internal energy an extensive property or an intensive property? Yes, it is an extensive property because it depends upon the quantity of matter. Very good. Moving on forward, now we will talk about the first law of thermodynamics. So first we talked about heat, work and internal energy. Before knowing the first law, you must know these three things. Further, if I talk about the statemental form of this thermodynamics, it says that according to this law, energy cannot be created, neither be destroyed in a process. Okay? And it can only be converted from one form to another. Mathematically, you can write it as delta U is equals to Q plus W, where Q is your heat, W is your work, and delta U is your internal energy change. It means that for a pressure volume type of work, the change in internal energy is equals to the total product of the heat exchange, total sum of the heat exchange and the work done. Okay, it only depends upon two things, which is the heat exchange and the work done. Then next, since W and Q both are not state function, we know that W and Q both are not state function, but W plus Q is a state function because it is equals to delta U. So this is very important to remember that Q and W are not individually a state function, but the addition of both is a state function which is your internal energy. Is it clear to you? Which is your change in internal energy. Okay, so each and every time I'm saying, I am just telling it as change rather than the absolute value, because it is impossible to calculate the actual value of the internal energy, and surprisingly we only need the change and not the actual value. Is it clear to you? Anyone who has a doubt till this point? Okay, so now we shall move forward. Next is our enthalpy. Now we'll study about enthalpy. Enthalpy is the total heat content of a system when pressure is kept constant, and it is the sum of internal energy and the pressure volume product. Remember, it is also an extensive property and also state function. Its symbol is capital H. The equation to calculate the enthalpy change is given as delta H is equals to delta U plus delta PV. If we take the pressure constant, as I said earlier, so that will be given as delta H is equals to delta U plus P delta V. In place of delta PV, you can directly write it as delta NGRT also. So these are the two cases of your enthalpy change calculation. In first case, you can keep the pressure constant, which will give you P delta V, or you can simply substitute the whole PV with delta NGRT. And this third equation that you are seeing is very important to calculate the enthalpy change for a process which involves a reaction, and that is keeping your temperature constant. So here delta H is your enthalpy change, delta Ng is the change in gaseous number of species. Why we are saying? Because we are substituting PV with nRT, and this is only valid for the gaseous phase. This is your gas law. Now we can have multiple cases. If your delta Ng is equals to 0, then in that case delta H and delta U both will have the same value. Next, if delta Ng is greater than 0, then in that case your delta H will be greater than delta U. Very easy to get. And if your delta Ng is less than 0, then your delta H is less than delta U. So these are the three cases you can get in a reaction. Now, for reactions involving solid and liquids only, delta H will be always equals to delta U, because there are no gaseous species involved in this reaction, and delta Ng is simply the difference between the gaseous number of species on the product side minus the gaseous number of species on the reactant side. Got it? So for liquids and solids reactions only, delta Ng is equals to 0 always. Next, enthalpy can also change when a substance undergo phase transition. Suppose if your liquid is changing to gas, or a gas is changing to liquid, or liquid changing to solid, then in that case also enthalpy change occurs. So this was all for the theory part. Now we will move on to the question. If you have a doubt till this part, you can just post it. Meanwhile, I am opening my questions. So here is your first question. Which of the following statement is true? First is the pressure of reacting species in a covered beaker is an example of open system. Second, there is an exchange of energy as well as matter between the system and the surrounding in a closed system. Third, the presence of reactants in a closed system made up of copper is an example of closed system. And fourth, the presence of reactants in a thermos flask or any other closed insulated vessel is an example of isolated system, sorry, closed system. So you are given some time to solve it. Please try to solve it within that time framework. So it's a very easy one. You can just comment the answer in the comment section. So these are all the JEE PYQs. Okay. If you can solve these questions, then hopefully you can solve it in the exam also for this chapter, which is thermodynamics. So this is an easy one. I am expecting everyone to solve this question. What will be the correct answer for this question? Which is the correct option? A, B, C, or D? Okay. Dhruva, Disha, Nandu, anyone who is willing to give the answer for to this question? Okay. So I hope you are not knowing the answer. So I'll move on to the correct answer. The correct answer to this question is option C. So it's a very simple one. You have to only tell that the which of the following is a correct statement. So as I said, option C is correct. It tells us that for a closed vessel which is made up of copper, matter cannot be exchanged. Okay, if it is closed with a lead, then matter cannot be exchanged in that case, but heat can be exchanged or energy can be exchanged because of the copper vessel, since copper is a metal and it is capable of conducting heat. So energy can be exchanged in that process, but not your matter. So a copper vessel, a closed copper vessel is an example of open system, sorry, closed system. So the correct option is C. Moving on to the next question. So here is the next question. An ideal gas expands in a volume from 1 into 10 to the power minus 3 meter cube to 1 into 10 to the power minus 2 meter cube at 300 Kelvin against a constant pressure of 1 into 10 to the power 5 Newton per meter square. The work done is, again this is simply based upon formulas. Uh, Options are A minus 900 joule, B minus 900 kilojoule, C 270 kilojoule, and D 900 kilojoule. So what will be the correct answer? Again, it is a directly formula based question. What you have to do is you have to calculate the work done. You are given the initial and the final volume, and also you are given with a pressure. You have to simply apply the formula minus P external dV. But the question is that whether it is a reversible process or an irreversible process. So this is the most important part you should know. Then and then only you will able to solve this question. Here is a hint for you. It is a irreversible process. And whenever you see that you are seeing a constant pressure, means the pressure is not varying, then in those cases you will always take irreversible process. Okay, got it? Anyone who got the answer, you can just post it here. Sorry. So how do we know this is an irreversible process? I'm getting answer as A. Very good. Anyone else who is willing to give the answer? Remember, as soon as you see a statement like this against a constant pressure or something like that, remember it is always taken as an irreversible process. Because in case of reversible process, you change the volume. Okay, external volume is not kept constant. Anyone else who is willing to give the answer to this question? Okay, now let us move on to the answer. So the correct answer will be option number A. Very good. How we'll solve it? It's very simple. Whenever you want to calculate the work done due to change in volume against a constant pressure, you use the formula W is equals to minus P V2 minus V1. Here, what is P? It is given as 1 into 10 to the power 5 Newton per meter square. What is your V? V2, which is your final volume, it is 1 into 10 to the power minus 2, and your initial volume is 1 into 10 to the power minus 3. You put all the values, you will get it as minus 900 Newton meter, and 1 Newton meter is simply your 1 joule. So, in place of minus 900 Newton meter, you can write it as minus 900 joule, which gives your correct answer as option number A. Next question. When 1 mole of a gas is heated at constant volume, the temperature is raised from 298 Kelvin to 308 Kelvin. Heat supplied to the gas is 500 joule. Then which statement is correct? So four statements are given here, and the heat gas is heated at constant volume, whereas the temperature is changing from 298 to 308 Kelvin, and heat supplied is also given. So it's a very easy one, because volume is kept constant. What will be equals to 0? Remember the formula, work done is equals to minus P delta V, where delta V is the change in the volume. So from there you can get your W, and if you know the W and heat is already given, which is your Q 500 joule, then you can easily calculate the delta U, which is simply the addition of Q and W. So what will be the answer for this question? Quickly give the answer in the comment section. Anyone who is willing to give the answer? It's an easy one, right? So please post your answer. You have to calculate the delta U here and Q and W. Remember, Q is already given in the question, which is 500 joule. W can be calculated as the volume is kept constant. So from there you can calculate the W, and if you know the Q and W, you can calculate delta U, which is equals to Q plus W. So what will be the answer for this question? Option C. Okay, let's see what will be the answer. I want more answers from you because it's a easy one, right? We have to simply calculate the internal energy, the work done, and the Q, where Q is already given in the question. Now, what will be the symbol of Q that you will take? Here it is said that heat is supplied to the system, right? So, in that case, what will be the sign convention? Will it be positive or will it be negative? Here, heat is supplied to the system. So, what will be the sign convention for Q? Whether we will take plus 500 joule or minus 500 joule. So, that is also something which you have to decide. We already talked about the sign convention in the theory part. Okay, so I will consider that you are not solving it. Moving on to the answer. The correct answer is C. Let us see how it is the correct answer. So at constant volume, P delta V will be equals to 0, right? Because the volume change is 0. So delta V is 0 and hence your P delta V is also 0. If this is true, then the work done is equals to 0. Okay. In case of bomb calorimeter, the volume is taken constant. Always. Then after, we know from the first law of thermodynamics that delta U is equals to Q plus W. If W is equals to 0, then delta U is equals to Q. Then after we know that heat is supplied to the system, so Q will be equals to plus 500 joule. Or we can write it as delta U is equals to delta Q is equals to 500 joule. So this is your final answer and work done will be taken as 0. Okay, so there are two kind of calorimeter, bomb calorimeter and simply calorimeter. In case of bomb calorimeter, you always take the volume constant, and in case of calorimeter, you take the pressure constant. Next question. In an adiabatic process, no transfer of heat takes place between system and surrounding. Choose the correct option for free expansion of an ideal gas under adiabatic condition from the following. Okay, so I think everything is mentioned here. What will be the correct answer for this? Let me give you a hint. So delta U has also a formula which is known as CV delta T, which is delta U at constant volume. So delta U is also calculated as CV delta U formula. Here you can use that formula to calculate the delta T. First, you know that it is an adiabatic process. So of course, Q will be taken as 0, right? So this is the first part. Second, you have to choose it for the adiabatic condition. In case of adiabatic condition, there is no external pressure, means the gas is expanding under no pressure and hence P external is taken as 0. That means work done is also 0. So Q is 0 and W is 0. So we can say that overall your delta U is 0. Got it? Easy to get. If delta U is 0, that means CV delta T, which is the formula for delta T for the delta U, is also equals to 0. But CV can never be 0. So delta T will be taken as 0. Okay. Yes, the correct answer will be C, which is delta Q is equals to 0, delta T is equals to 0, and W is equals to 0. So here we are using three things. first of all, you know that adiabatic condition, so Q is 0. Second thing, we are taking a free expansion, therefore your P external is equals to 0. And third thing, if Q and W are 0, then delta U is 0, and hence CV delta T is equals to 0, and that gives your delta T value as 0. Let us move on to the solution. The correct answer will be C. As I said earlier, it's very easy to say that in the case of free expansion, there is no external pressure. It is expanding freely. You are not applying any external pressure onto it. If Pxt is 0, then we know that work done is equals to minus P external delta V, and keeping the value of P external delta V, you will get your work done as 0. So this is the first part. Then after, second thing, since it is an adiabatic process, so Q will be also equals to 0. If Q and W are 0, that means internal energy is not changing. And remember, I said it earlier that for constant temperature, what did I say? For constant temperature, internal energy is 0. So if delta U is equals to 0, then the reverse is also true. So what I am saying is that we have seen a line which says that at constant temperature, the change in internal energy is 0. The opposite is also true. If the internal energy change is 0, then delta T is equals to 0. So I will tell you the formulas, which is CV delta T and CP delta T, within the theory part or within the question part. You have to note it down by yourself. Okay. So meanwhile, we will deal with the question. We will look upon each and every important formula. So you don't have to worry about that. Okay. So we can say that Q is equals to 0, delta T is equals to 0, and W is equals to 0. I've seen a lot of students doing this mistake. So first of all, you should know how to use the formulas that you already know. Okay, rather than moving on or buzzing for those formulas which are not known to you. Maybe there is a chance that you can get a question from the formula that you already know, but since you are not aware about the methodology to solve the question, you can miss that, and that is something which is very upsetting. Okay, rather than not knowing a formula, it is very upsetting to know a formula and then not to solve a question. So you don't have to be eager about that. Just go along with the lecture. You will get your important formulas within the lecture. Just note it down, and then you will see that questions can be solved easily, because these are P by Qs. If you can solve P by Qs, then of course there is a high chance that you can solve the questions which will be asked in your future exams. Next question. 1 mole of an ideal gas at 300 Kelvin is expanded isothermally from an initial volume of 1 liter to 10 liter. The delta U for this process is, R is given as 2 calorie per Kelvin per mole. Options are 270 calorie, 0, 10 liter ATM, and 181.7 calories. So here you have to calculate the delta U. It is already given that the system is expanding isothermally. So we have already seen the impact of isothermal process on internal energy, and this is a very easy question if you know the exact concept behind the internal energy relation and temperature. So what is the correct answer? If the process is occurring isothermally, what is the internal energy change? Anyone? It's a very easy one. What is the answer for this question? What will be the internal energy change in case of isothermal process? So it is a tricky question. There are lots of information, but you have to use them wisely, which is useful for you and which is given just to deviate you from the correct answer. So many times you will see in thermodynamics, data which is not useful is given in your question, and that may deflect you or deviate you. So I am seeing an answer here which is B. Let's see if it is correct or not. Anyone else? who is willing to give the answer to this question? So it's a very easy one. It is already given that the process is isothermal and you have to just calculate the delta U. Here the correct answer will be B. Why B? Because heat at constant volume is given as delta U is equals to Cv delta T. We know this formula, I told you earlier. But as the temperature is kept constant in an isothermal process, as we know, so delta T is equals to 0. If delta T is equals to 0, we can easily say that delta U is also equals to 0. Got it? Moving on to the next question. So this was asked in JEE Main 2017. You have to say that delta U is equals to which of the following work: isochoric work, isobaric work, adiabatic work, or isothermal work. Again, it's a easy one. What will be the correct answer for this question? It will directly come from the mathematical formula of first law of thermodynamics. If you know this, you can just comment it here. It's a very easy one. Anyone who is willing to give the answer to this question? So it is a recent year question. You have to simply say that delta U is equals to which of the adiabatic work. Okay, so I'm seeing an answer. Answer C. Let's see if it's correct or not. Anyone else? So I'm expecting answer from this. So I'm not telling that work done is 0. I'm telling you that delta U is 0, right? So it is possible that the sum of Q and W is 0, but I'm not telling you that W is 0. You got my point? So you're telling the volume is not constant. No problem. You will get some work, but that doesn't mean that delta U is not equals to 0. It is the individual value of W. So in that question, most probable chance is that W and Q both are equal in nature but opposite in sign, and that is giving you a 0 internal energy. You got my point? Okay. So I'm seeing more answers. D, C, C. Let's see which one is correct. The correct one is option number C. So it's a very easy one. We know that from the first law of thermodynamics, delta U is equals to Q plus W is equals to Q minus P delta V. Then next, in isochoric process, delta V is equals to 0. Therefore, your delta U is equals to Q. This is not correct because you have to tell it that for which one it is equals to the work. Next is isobaric process where delta P is equals to 0. In that case, you will not get any value which is equals to 0. So again, this is not the correct answer. Third one, adiabatic process, Q is taken as 0. If this is true, then delta U will be simply equals to W. Got it? Lastly, we have isothermal process. In isothermal process, delta U is itself equals to 0 and not equals to the work done. So, did you get my point? Why I was saying that you don't have to look upon volume to calculate the internal energy change? So you got confused because you thought that if the work done is not equals to 0, how delta U can be equals to 0? Now is it clear to you? Was asking about 1 and 10 liter. I said that it is possible that the volume is changing and with respect to that you will get some work also, but that same amount of work is done with the help of Q, which is your heat, but in the opposite sense, and that is the reason your delta U is equals to 0. Okay, now thank you for giving the answer. Now in the isothermal process your delta U is equals to the adiabatic process. This is clear from these 4 discussions. Moving on to the next question. So again it was asked in 2013. A piston filled with 0.04 mole of an ideal gas expand reversibly from 50 ml to 375 ml at a constant temperature of 37 degrees Celsius. As it does so, it absorbs 208 joule of heat. The value of Q and W for the process will be, so R is given in the question, which is 8.314 joule per mole per Kelvin, and Ln 7.5 value is given, which is 2.0.1. So you are given with all the values. You don't have to look for the log table to know the value of Ln 7.5. It is there in the question. Now options are given for different values of Q and W. You have to tell that which is the correct one. So what will be the answer to this question? Anyone? What will be the correct answer to this question? So I'm already seeing some answers. D, option D. Let's see if it is correct or not. So I will expect more of you to give your answer in the comment section. I will just tell you that you should attempt the DPPs also as well after the class is over. So I will today let you introduce with how to solve the DPP and where you can access it if you don't know about it. Okay, moving on to the answer. The correct answer will be D. How will solve it? So the process is carried out at constant temperature, and hence this expansion will be named as isothermal reversible expansion. Now for this kind of process, you know that delta U is equals to 0. Next, we know that Q is equals to minus W. Okay. So this is very obvious. If delta U is 0, then from the first law of thermodynamics, Q will be equals to minus W. Then it is already given in the question that Q value is 208, minus 208, because it is absorbed by the system. Therefore, Q will be equals to plus 208 joule, and hence work will be minus 208 joule. Now there are two ways you can solve it. The first way is that you go through that long process from the formula of which is minus nRT ln V2 by V1. Or you can simply use this logic, which says that if the temperature is kept constant, then Q will be equals to minus W, and Q is already given in the question, which is plus 208 joule. So the negative of that Q will be equals to work done, which is minus 208 joule. You got it? So we can say that the correct value of Q is plus 208 and W is minus 208 joule. Any doubt till this point, or in any question that we have passed through? You can ask it right now, because now I will move on to the DPPs. Is it clear to you? Kavita Desai, did you get your mistake? What was the mistake that you were doing while giving the answer? So did you analyze your mistake? Why did you get the answer as B? Okay, so now we shall move on to the DPPs. So I will show you how to attempt the DPPs, right? So just wait for a while. Meanwhile, I will switch on to the DPPs. So this is our website. Now in this website, you can easily see that there is written JEE Mains 2026 crash course. Got it? So just go and click here. Okay, just go and click here. You will see that on the left hand side we have various things. So we have our crash course, we have our detailed course here. Then go to this crash course part. Further, you can click on view lectures. From here, what you can do, you can move on to chemistry, and from here you can look onto our old videos or the lectures that have been already taught. Next, moving on further, so we are today doing questions on chemical thermodynamics. Suppose if you want to solve the DPP for after attending today's class, what you will do? You will simply click on this DPP and try to solve it. Suppose we learnt about this chemical bonding in the previous class and we want to solve DPPs for it. Then what we will do? You will click here DPP daily practice problem, and this whole framework is exactly same as your current JEE pattern. Next, just click on this checkbox and click on proceed. Got it? So this test is already attempted. You can try this by yourself also. Suppose this is your first question and it is asking you which species is having a bond order of 1.5 and which will contain p pi d pi. So what will be your answer? So for this types of question, how you do you attempt it? First, you need to calculate the bond order. How do we calculate the bond order? If you are not able to solve any question, you can just join our doubt sessions as well. So if you just go back here, you can see here that we have a doubt session right here, daily live doubt clearing session. From here, you can come here and ask question related to the DPP that you were not able to solve during our DPP attempt, and then we will give you the answer along with it. Okay. So in this way you can do it. So as I said, so suppose we are attempting this question. Let us do a DPP. Okay. So this is being attempted already. You have to say that which is the correct answer in this. So in this type of question, what do? You simply calculate the bond order. First of all, let us draw the structure of IO2 F2 minus. So this is IO2 F2 minus. This will be your structure. Okay. Now, next, what we can do? We can have a second structure for this, second resonance structure for this, which will be like this. right? So this is the most probable structure that we can have. Now, this is your structure, okay? Next, here the bond order will be equals to 1.5. How do you calculate the bond order? It's very simple. So there are total of 3 bonds. Between iodine and oxygen, there are 3 bonds. One is here and 2 are here. So 3 is the number of total bonds, and what are the possible delocalizations that are possible? So one for this oxygen and second for this oxygen. So in this way you can calculate it as 1.5. So it's very simple. Just calculate the number of bond and divide it by the number of locations which are possible for the electron for resonance, and that will give you your bond order. Okay. So the correct answer will be first one, and again it will have a p pi d pi bond. So in this way you can just attempt our DPPs. Suppose I move on to the next question. So explanation also is given in the question. You don't have to worry about the explanation if you are not able to solve it. You can look for the explanation as well. After that, still if you are getting any problem, then you can move on to the live doubt clearing session. Here is our second question. Suppose you have to see that what is the bond order for the given B2 plus, which is beryllium 2 plus. So for beryllium 2 plus, the electronic configuration is given here: sigma 1s2, sigma star 1s2, then we have sigma 2s2, sigma star 2s2. What is the total number of bonding electron? It is 4. And what is the number of anti-bonding electron? It is 3. So 4 minus 3 equals to 2, and 2 by 2 gives you 1. Sorry, 4 minus 3 is equals to 1, and 1 by 2 gives you 0.5. Next, you have to calculate the double of this bond order, which will be 2 into x, which is 1. So the correct answer will be 1 here. Okay, so this was all for today's class. Next, our math session will start in few minutes. Just wait for a while.
Hello student. So in today lecture we are going to discuss the theory of determinant. This is our disclaimer and this is a trend analysis according to last 5 years, right? You can see that the chapter weightage is 5.53% and this is a yearly question distribution. So you can see that in 2024 there is one question from this chapter based on the topic determinant of matrix and difficulty level is easy, right? And in year 2023 there are three questions from this chapter based on the topic determinant of matrix, adjoint of a matrix and solution of a system of linear equation, and difficulty level is easy and average. In year 2022 there is one question from this chapter based on the topic system of a linear equation and difficulty level is average. In year 2021 there is two questions from this chapter based on the topic inverse of matrix and system of linear equation and the difficulty level is average. So this is your index. So first we will tell you about determinant, what determinant are and what is the relation between determinant and matrices, right? And then I will tell you, if you have a 2 cross 2 matrix or 3 cross 3 matrix, then how to find the determinant. After that we will tell you about the properties of determinant, and then in the last I will tell you about cyclic determinant. So let's start the determinant. So with every square matrix a number or expression can be associated which is called its determinant, right? And it is denoted by determinant of a or delta. So now you will understand that the definition of a determinant is that if you have any square matrix, then we can associate every square matrix with a unique number or expression, that is called the determinant. So if you assume that we have a square matrix whose order is n cross n, means in this matrix we have a n row and n column, then its determinant will be written in square type bracket. Like, see that here we have a matrix A of order n cross n, right? And the element in the matrix is a11, a12 dot 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 a1n, right? And the element of the second row is a21, a22 dot 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 a2n, and then the element of the nth row is an1, an2 dot 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 ann, right? And if you want to calculate the determinant of this matrix, so we need to represent the element of this matrix in a square bracket. See that the determinant of a equals to, in square bracket, the element of the matrix a11, a12 dot 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 a1n, then we have a21, a22 dot 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 a2n, and then we have an1, an2 dot 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 ann. So if you take a 2 cross 2 matrix whose element are a, b, c, d, then the determinant of that matrix will be determinant of a, b, c, d. This means to find the determinant of 2 cross 2 matrix, we multiply a and d, and then we multiply b and c, and then we will take a difference of AD and BC. So the determinant of this 2 cross 2 matrix will be AD minus BC. So similarly, if you have a matrix of order 3 cross 3, it means that, let's suppose we have a matrix in that we have a 3 row and 3 column. Let's suppose we have A equals to ABC, PQR and UVW, right? And we need to find what will the determinant of this matrix. Then we can calculate the determinant of this matrix using this formula, right? So here, to calculate the determinant of A, we are going to expand this determinant along the row 1, right? So how we can expand? So first we need to write the first element right? And then we need to remove the first column and first row, right? And then we need to take the determinant of the remaining element, right? So let's suppose we will take A. So when we will remove the first row and first column, so we have the remaining element Q R V W, right? So we need to take the determinant of this. So determinant of A equals to A times Q R V W, right? Then minus second element of the first row, that is B. So minus B. Then we need to remove the first row and second column and take the determinant of the remaining element, right? So it means that minus B times P R U B. U W means determinant of P R U W plus C, and we need to remove the first row and third column, right? And we need to take the determinant of the remaining element. It means that plus C times what is the remaining element? P Q U V, right? And we need to take the determinant of this. So plus C times determinant of P Q U V, right? So if you have a matrix A of order 3 cross 3 and you want to find what will the determinant of A, so you can use this formula, right? But please note that here we have expand the determinant along row 1. So the determinant will be determinant of A equals to A times, and we know that how to calculate the determinant of 2 cross 2 matrix, right? So determinant of QR V W will be QW minus VR minus B. The determinant of PR UW will be PW minus UR, right? So we will get minus B times PW minus UR, right, plus C. And the determinant of PQUV will be PB minus UQ, right? So if we have a matrix of order 3 cross 3, right, and we need to find what is the determinant, so determinant of A equals to A times QW minus VR minus B times PW minus UR plus C times PB minus UQ. So now suppose you have a 3 cross 3 matrix, then it will have 3 row and 3 column. So you can expand the determinant of any 3 cross 3 matrix in 6 way. For example, we have expanded along row 1. Similarly, you can expand along row 2 and row 3, right? And in the same way, you can expand along the column 1, column 2 and column 3, right? So if you have a matrix of order 3 cross 3, so you can expand the determinant of this 3 cross 3 matrix in 6 way. So now we will see a note. So now we are going to discuss that rule to put plus or minus sign in the expansion of determinant of order 3. So this is the rule. So if you are expanding along row 1, so the sign of first element will be plus and the sign of second element will be minus and the sign of third element will be plus. Similarly, if you are expanding along row 2, so in that case the sign of first element will be minus and the sign of second element will be plus and the sign of third element will be minus, right? And if you are expanding along row 3, so in that case the sign of first element will be plus and the sign of second element will be minus and the sign of third element will be plus, right? So here we have used the formula minus 1 की power I plus j. I stand for row and j stand for column. So see that we know that the first element is a11. So here we have the value of I equals to 1 and also we have the value of j equals to 1. So what will the sign? Minus 1 की power 1 plus 1, that is minus 1 की power 2, which is equals to 1. So that's why when we will expand along the row 1, so the sign of first element will be plus. Similarly, if you are expanding along row 1, so in that case the sign of second element is minus. How? See that in the second element we have the element name, that is a12, here row 1 and column 2. So when we'll apply the formula minus 1 की power I plus j, so I equals to 1 plus j equals to 2, so we will get minus 1 की power 1 plus 2, right? So this is equals to minus 1 की power 3, this is equals to minus 1. So that's why the second sign we have minus and the third sign we have plus, because the third sign here, this is the element a13, here we have I equals to 1 and j equals to 3. So minus 1 की power 1 plus 3, that is equals to minus 1 की power 4, that is equals to plus, right? So similarly you can find the sign of all the element, right? And the next point is that if you have a square matrix A is said to be singular if determinant of A equals to 0, and we will say that a square matrix is non-singular if determinant of A equals to not equals to 0, right? So let's suppose you have a matrix A and you need to find either this matrix will be singular or non-singular. So you just need to calculate the determinant. If you are getting determinant of that matrix equals to 0, so you can say that that matrix is singular, and if you are getting determinant of that matrix not equal to 0, so you can say that that matrix is non-singular, right? So now we are going to discuss the property of determinant. So the first property is that if each element of a row or column is 0, then the value of determinant equals to 0, right? So this is the first property. Let's suppose you have any matrix and where each element of any column or any row is 0, so in that case the determinant of that matrix will be 0. And the second property is that if two row or column are proportional, so in that case the value of determinant will be 0. Here proportional means constant multiple, right? So let's suppose two row are proportional, it means that if one row is constant multiple of another row, right, so in that case the determinant of that matrix will be 0. And the column proportional means if let's suppose we have a two column that are proportional, it means that one column is so I'm saying that if two column are proportional, it means that if one column is constant multiple of another column, so in that case we will get that determinant of that matrix equals to 0, right? And the third point is that the determinant of A transpose equals to the determinant of A, right? And the fourth point is that if any two row or two column are interchanged, in that case the value of determinant will be negative of the original determinant. Let's suppose we have a matrix A and we are getting the determinant of A equals to 5, right? And we are interchanging the two row. So what will be the determinant of the new matrix? So the determinant of new matrix will be minus 5, right? So similarly, let's suppose we have a matrix A and we are getting the determinant of this matrix equals to 6, and we are interchanging two column. So what will be the determinant of new matrix? So the determinant of new matrix will be minus 6, right? The fifth point is that if every element of any one row or column of a determinant is multiplied by a constant k, so in that case the value of new determinant will be k times the value of the original determinant, right? And the sixth point we have the determinant of k times a equals to the k की power n times determinant of a if a is a matrix of order n cross n. So here k की power n, so what is the n here? N is the order of the matrix, right? So let's suppose we have a matrix A whose determinant is 3, right? So we have a matrix A of order 2 cross 2 whose determinant is 3, right? So what will the determinant of 2 times A? So this will equals to 2 की power 2 times determinant of A, right? And the last point is that if every element of any row or column of a determinant is written as the sum of two or more terms, so in that case the determinant can be written as the sum of two or more determinant, right? So let's suppose we have a matrix and is a1 plus a2 b c p1 plus p2 q r u1 plus u2 v w, and we want to find what will the determinant of this matrix. So see that here the element in the first column are written in two terms, so that's why when we will calculate the determinant, so determinant will also be written in the two terms. That means that this determinant will equals to determinant of a1 b c p1 q r u1 v w plus determinant of a2 b c p2 q r u2 v w. So now we are going to discuss the next property, that is if the scalar multiple of any row or column is added to another row or column, so in that case the value of determinant will not change, right? It means that the value of determinant will remain same. So let's suppose we have a matrix, we want to find the determinant of a b c p q r u v w, right? So this determinant is equals to determinant of a b c p plus ka q plus kb r plus kc u v w, right? Which is obtained by the operation r2 equals to r2 plus kr1, right? So here we have applied the operation r2 equals to r2 plus kr1. It means that in the row r2 we have added the k times row r1, right? So in this case the value of determinant will not change, right? So it means that the value of the new the value of the determinant of the new matrix will remain same. So now we'll talk about the product of determinant, right? Suppose we have a two determinant, that is determinant of a equals to determinant of a1 b1 c1 a2 b2 c2 and a3 b3 c3, and determinant of b equals to alpha 1 beta 1 gamma 1 alpha 2 beta 2 gamma 2 alpha 3 beta 3 and gamma 3. Then determinant of a times determinant of b will equals to the first element will be when we will multiply the first row of determinant of a to the first row of determinant of b, that is when we'll multiply a1 b1 c1 by alpha 1 beta 1 gamma 1, right? So we will get a1 times alpha 1 plus b1 times beta 1 plus c1 times gamma 1, right? So this is our first element, and the second element means a12 will equals to when we'll multiply the first row of the determinant a to the second row of determinant b, that is when we'll multiply a1 b1 c1 by alpha 2 beta 2 gamma 2, right? So we will get the value of a12, right? So that it means that the a12 will be a1 alpha 2 plus b1 beta 2 plus c1 gamma 2, right? So the value of a13 will be when we'll multiply the first row of determinant of a to the third row of determinant of b, that is when we'll multiply a1 b1 c1 by alpha 3 beta 3 and gamma 3, right? So we will get that a1 alpha 3 plus b1 beta 3 plus c1 gamma 3, right? So this is the value of a13, right? So and now the value of a21 will be when we will multiply the second row of determinant of a to the first row of determinant of b. That is, if you multiply a2 b2 c2 by alpha 1 beta 1 gamma 1, right? So we will get the value of a21. It means that we will get a21 as a2 alpha 1 plus b2 beta 1 plus c2 gamma 1, right? So to calculate the value of a22, we will multiply the second row of determinant of a to the second row of determinant of b. That is, we will multiply a2 b2 c2 by alpha 2 beta 2 gamma 2, right? So we will get a2 alpha 2 plus b2 beta 2 plus c2 gamma 2, right? And to calculate the value a23, we will multiply the second row of determinant of a to the third row of determinant of b. It means that we will multiply a2 b2 c2 by alpha 3 beta 3 gamma 3, right? So we will get a2 alpha 3 plus b2 beta 3 plus c2 gamma 3, right? So now we are going to calculate the element a31. So to calculate the value of a31, we need to multiply the third row of determinant of a to the first row of determinant of b. That is, we need to multiply a3 b3 c3 to alpha 1 beta 1 gamma 1, right? So when we will multiply this, so we will get the value of a31 as a3 alpha 1 plus b3 beta 1 plus c3 gamma 1, right? Now to calculate the value of a32, we are going to multiply the third row of determinant of a by second row of determinant of b. That is, a2 b3 c3 a3 b3 c3 by alpha 2 beta 2 gamma 2, right? So we will get a32 as alpha a3 alpha 2 plus b3 beta 2 plus c3 gamma 2, right? Now to calculate the value of a33, we are going to multiply the third row of determinant of a by third row of determinant of b. That is, we are going to multiply a3 b3 c3 by alpha 3 beta 3 gamma 3, right? So we will get the last value as a3 alpha 3 plus b3 beta 3 plus c3 gamma 3, right? So here we have calculated the value of determinant of a times determinant of b. So we will get that determinant of a times determinant of b equals to the determinant of ab, right? So please note that the determinant of ab equals to the determinant of a times determinant of b. This is equals to the determinant of ba, and this is equals to the determinant of a transpose b, and this is equals to the determinant of ab transpose, right? And this is equals to the determinant of a transpose b transpose, right? So let's suppose you have the value of determinant of a is equals to 2 and determinant of b equals to 3, right? And you want to find that what will the value of determinant of a transpose b transpose, right? So you just need to multiply determinant of a by determinant of b. That is, you will get that the value of determinant of a transpose b transpose equals to 6, right? And the last point is that the determinant of a की power n equals to the determinant of a की power n, right? But here there is one condition. What is that? N belongs to z plus, right? Now we'll talk about the cyclic determinant. So in a cyclic determinant, the element of row and column are arranged in a systematic order, and also the value of determinant is also in a systematic order, right? So this is the first type of cyclic determinant. So here the value of determinant 1 x x square, 1 y y square, 1 z z square will be equals to x minus y times y minus z times z minus x, right? Similarly, the determinant of 1 x x cube, 1 y y cube, 1 z z cube will equals to x minus y times y minus z times z minus x times x plus y plus z. Similarly, if you will calculate the determinant of 1 x square x cube, 1 y square y cube, 1 z square z cube, so you will get this value as x minus y times y minus z times z minus x times xy plus yz plus zx, right? And if you will calculate the determinant of a b c, b c a, c a b, you will get this value as minus times a plus b plus c times a square plus b square plus c square minus ab minus bc minus ca. So this is equals to minus a cube plus b cube plus c cube minus 3a bc. And if you will calculate the determinant of a bc abc, b ca abc, c ab abc, so the determinant of this matrix is equals to the determinant of a square a cube, b b square b cube, c square c cube, right? So see that here we can take a as a common from the first row. Similarly, we can take b as a common from the second row, and we can take c as a common from the third row. So what we will get? We will get abc times determinant of 1 a square, 1 b square, and 1 c square. And we know that the determinant of 1 x x square, 1 y y square, and 1 z z square is equals to the x minus y times y minus z times z minus x, right? So here in place of x we have a, in place of y we have b, and in place of z we have c, right? So we can write that abc times a minus b times b minus c times c minus a. So wait a student, now we are going to solve the question based on the theory which we have discussed. So now we are going to solve a question based on the theory which we have discussed. So this is your disclaimer part. So this is your index. So in this we will solve from question 1 to question 6, right? So let's start. So this is our first question. So in this question we have given that if x equals to cy plus bz and y equals to az plus cx, and we have given z equals to bx plus ay, where x, y and z are not all 0, then we need to find that what will be the value of a square plus b square plus c square, right? And we have a given 4 option. First option is 1 plus 2abc. The second option we have given 1 minus 2abc. The third option we have given 1 plus abc, and the fourth option we have given abc minus 1, right? So we need to find which option is correct, right? So please try to solve this question, student, then we will discuss the solution. Yes, everyone, please try. Yes, please try. Okay, let's start the solution. So the correct answer is B, right? Not D. The correct answer is B. So now we will see how the B will be true, right? So the given equation can be written as, so see that the first equation we have given x equals to cy plus bz, right? So we can rewrite this equation as x minus cy minus bz equals to 0, right? And the second equation we have given y equals to az plus cx, right? So we can rewrite this equation as cx minus y plus az equals to 0. And we have given the third equation z equals to bx plus ay. So we can write this equation as bx plus ay minus z equals to 0. Since in the question it is given that x, y and z are not all 0, right? So since x, y and z are not all 0, so in that case we can say that the above system has a non-trivial solution, right? We will get the trivial solution if x, y and z are all 0, right? But it is given that x, y and z are not all 0, right? So in that case we will get a non-trivial solution, right? And since we are getting the non-trivial solution, it means that the determinant of coefficient matrix will be 0, right? So let's see that how we can write this matrix. So see that the first row is the coefficient of x, y and z in the first equation, right? So what is the first equation we have? So the first equation we have x minus cy minus bz equals to 0. And here what is the coefficient of x? So the coefficient of x we have 1. So that's why the first element in the first row is 1, and the coefficient of y in the first equation we have minus c. So that's why the second element in the first row we have minus c, and the coefficient of z equals to minus b in the first equation. So that's why the third element in the first row is minus b, right? So similarly we can write the second row. How we can write? So the first element of the second row will be the coefficient of x in the second equation, right? And the coefficient of x in the second equation we have c. So that's why the first element in the second row will be c, right? And the second element in the second row will be the coefficient of y in the second equation, and we have the coefficient of y is -1 in the second equation. So that's why the second element of the second row will be -1, right? And the third element of the second row will be the coefficient of z in the second equation, right? And in the second equation the coefficient of z is a, so that's why the third element in the second row will be a, right? Similarly, the element of the third row is the coefficient of x, y and z in the third equation, right? In the third equation the coefficient of x is b, coefficient of y is a, and the coefficient of z is -1. So that's why the element in the third row is b a -1, right? And this determinant equals to 0 because the system has a non-trivial solution, right? So when we will expand this determinant along the row 1, so we will get this value as 1 times 1 minus a square plus c times minus c minus ab minus b times ac plus b equals to 0, right? So when we will simplify this, so we will get that 1 minus a square minus c square minus abc minus abc minus b square equals to 0. So when we will simplify this, so we will get that the value of a square plus b square plus c square equals to 1 minus 2abc, right? So here we have calculated the value of a square plus b square plus c square, right? So see that to calculate the value of a square plus b square plus c square, first we have rewrite the given equation, right? And then we have applied the rule. What is the rule we have applied here? We have applied the rule here is that if x, y and z are not all 0, so in that case the system has non-trivial solution, and we know that if system has a non-trivial solution, so in that case the determinant of the coefficient matrix of x, y, z equals to 0, right? So we have applied that formula, and from there we have calculated the value of a square plus b square plus c square, right? And we have found that this value is equals to 1 minus 2abc, right? So that's why option b is correct. So now we are going to solve the next question. So in this question we have given that consider the set A of all determinant of order 3 with entry 0 or 1 only, right? And also we have given that b be the subset of A consisting of all determinant with value 1, and also we have given that c be the subset of A consisting of all determinant with value -1, right? Then we need to find that which option is correct. So we have given 4 options. So the first option we have given that c is empty, right? And the second option we have given that b and c have the same number of element, right? And the third option we have given that a equals to b union c, and the fourth option we have given that b has twice as many element as c, right? So we need to find that which option is correct, right? So please try to solve this question, then we will discuss the solution. Yeah, please try to solve this. Here in this question you just need to see the property of a, b and c, then you can find which option is correct. Everyone please response. Yes, okay. Yes, Varsa. D. Okay, we will see that. Everyone please response. Which option is correct? Yes, so here you just need to apply the property of A, B, and C. Then you can easily find like which option is correct. Okay, and let's try. Let's see the solution. So the correct answer is B. No, Varsa. The correct answer is B. So let's see that how B will true. So we have given that C be the subset of A consisting of all determinant with value minus 1, right? So from here we are saying that C is non-empty. Why? Because C is the set of matrices with determinant minus 1. For example, if we will take this matrix M equals to 1 0 0 0 0 1 0 1 0. So this matrix is belonging to C. Why? Because if you calculate, because if you will calculate the determinant of this matrix, so you will find that the determinant is 1, determinant is minus 1, right? So that's why we can say that this matrix is belongs to C, right? So we can say that C is non-empty, right? Because we have found one matrix that is belonging to C. So also A is not equals to B union C, because A also contains matrix with determinant 0. See that. What is the B? We have given that B be the subset of A consisting of all determinant with value 1. And what is C? We have given that C be the subset of A consisting of all determinant with value minus 1. So what is the value of B union C? So in B union C, it is also a subset of C, but in B union C, we have the matrix where the determinant is either 1 and minus 1, right? So if you see that in A, what we have given, A is the set of all determinant of order 3 with entry 0 or 1 only. So if we will consider the matrix M equals to 0 0 0, then 0 1 0 and 0 0 1. So this matrix is belonging to A. Why? Because in this matrix all the entries are either 0 or 1. So we can say that this matrix M equals to 0 0 0 0 1 0 0 0 1 is belonging to A, right? But what will be the determinant of this matrix? The determinant of this matrix will be 0, right? So we can say that, na, so this matrix is not belonging to B union C. Why? Because we know that in B union C is the set of all the matrix where the determinant is either 1 or -1. But we are getting the another matrix from A. We are getting the another matrix from A so that the determinant of this matrix is 0, right? So we can say that A is not equals to B union C. And if you interchange any two row of determinant in the set B, so its value become -1, and hence it is in C. What is B we have? We have given that B be the subset of A consisting of all determinant with values 1, and we know that, let's suppose we have a matrix A, and if we are interchanging two row, so in that case the determinant of new matrix will be minus times the determinant of original matrix, right? So let's suppose we have any matrix in B, right? So what will the determinant of that matrix? The determinant of that matrix will be 1. But when we are interchanging the two row, so what will the determine? So the determinant will be -1, right? So since the determinant is -1, so what we can say? We can say that, now this matrix is belonging to C, right? So similarly, if you have a any matrix in C, so in that case the determinant of that matrix will be -1, right? And if you are changing any two row, so we know that if you have a matrix A and if we are interchanging any two row, so in that case the determinant of new matrix will be minus times the determinant of original matrix, right? So let's suppose we have any matrix in C, so the determinant of this matrix will be -1, and when we are interchanging any two row, so the determinant of new matrix will be minus time -1, which is equals to 1. So we can say that, now this matrix is belonging to B, right? Because we are getting the determinant equals to 1, right? So what we can say? We can say that B and C have the same number of element, right? So that's why the correct answer is B. So now we are going to discuss the next question. So in this question we have given that if x, y and z are positive, then we need to find that what will be the determinant of 1, then log of y base x, log of z base x, then we have given log of x base y 1, log of z base y, and then we have given the third row as log of x base z, log of y base z, and then 1. We need to find that what will the value of determinant, right? And we have given four options. So the first option we have given 0, the second option we have given 1, the third option we have given -1, and the last option we have given that none of these, right? So we need to find that which option is correct, right? So please try to solve, student, then we will discuss the solution. Yeah, please try to solve. Here you can simplify this matrix by using the property of log b base a, right? So you just need to use the this property, and then you can easily find that what will the value of this determinant. Yes, so please try to solve this. Yes, please try. Anyone? Okay, let's start the solution. So the correct answer is A, right? So now we will see that how A will be true. So we need to find that the determinant of this matrix, that is delta equals to 1. Then second entry we have log y base x, then log z base x, then we have log x base y, and 1 log z base y, then log x base z, then we have log y base z, and 1, right? So we need to find what will be the value of delta, right? So the value of delta equals to, we can write 1 as log x by log x, right? And to simplify log y base x, we have used the formula. What is that? We have simplified log y base x as log y divided by log x, right? Similarly, we can simplify this log z base x as log z divided by log x, right? And then we can simplify log x base y as log x divided by log y, right? And we can write 1 as log y divided by log y, right? And then we can simplify this log z base y as log z divided by log y, right? And we can write this log x base z as a log x divided by log z, right? And also we can simplify this log y base z equals to log y divided by log z, and we can write 1 as a log z by log z, right? So here we have used one property, that is log a base b equals to log a divided by log b, right? So by using this property we have simplified this determinant, right? So now we are going to take the common factor from the row, right? So after taking the common factor from the row, we can rewrite this value of determinant delta equals to, from the first row we are going to take common 1 by log x, and from the second row we are going to take common 1 by log y, and from the third row we are going to take a common 1 by log z, right? So then we can write the value of determinant delta equals to 1 by log x times log y times log z times determinant of log x log y log z, then we have log x log y log z, then again we have log x log y log z, right? So now we are going to take common factor from the column, right? So from the first column we'll take log x as a common, from second column we will take log y as a common, and from the third column we will take log z as a common, right? So when we will take this log x, log y, log z common from the first, second and third column, so we will get the value of delta equals to log x times log y times log z divided by log x times log y times log z, then determinant of 1 1 1 1 1 1 1 1 1, right? So then since log x log y log z will cancel out, right? So that's why we can rewrite the value of determinant delta equals to determinant of 1 1 1 1 1 1 1 1 1. So the value of this determinant equals to 0, because here all the value in the row are same. So that's why when we'll calculate the determinant, so we will find that the value of determinant equals to 0, right? So here we have calculated the value of this determinant, and we have found that the value of this determinant equals to 0. So now we are going to discuss the next question. So in this question we have given that if A, B and C are cube root of unity, then we need to find that what will the value of the determinant e की power a, e की power 2a, e की power 3a minus 1, e की power b, e की power 2b, e की power 3b minus 1, and the third row we have given e की power c, e की power 2c and e की power 3c minus 1, right? And we have given four options. So the first option is 0, the second option is e, the third option is e square, and the fourth option we have given e की power 3, right? So we need to find that which option is correct, right? So please try to solve this question, student, then we will discuss the solution. Here you need to use one property. What is that? See that the third column is written, the element of the third column in is written in the two terms, right? So when we will calculate the determinant of this matrix, so we can also calculate the matrix in two terms, means we can also calculate the determinant of this matrix in two terms, right? So the determinant will also divide into two terms, right? Yeah, so you just need to apply this property and then you just need to calculate the determinant. Yeah, so please try to solve. Okay, let's start the solution. The correct option is A. Right? And now we will see that how A will be true. So the value of the determinant we can write in two terms. Why? Because the element in the third column is written in two terms, so that's why, right? So the value of the determinant delta equals to e की power a, e की power 2a, e की power 3a. In the second row is e की power b, e की power 2b, e की power 3b, and the third row we have e की power c, e की power 2c, e की power 3c minus the first row will become e की power a, e की power 2a, then 1, right? And the second row will be e की power b, e की power 2b, 1, and the third row will be e की power c, e की power 2c and 1, right? So here we have break down the determinant into two parts, right? So from the first part of determinant we can take e की power a as common from the first row, we can take e की power b as a common from the second row, and we can take e की power c as a common from the third row, right? So we can write the value of determinant delta equals to e की power a times e की power b times e की power c times determinant of 1 e की power a, e की power 2a, then the second row will be 1 e की power b, e की power 2b, and the third row will be 1 e की power c, e की power 2c, right? See that from the second part of determinant we have interchanged the second and third column, and we know that when we will interchange the any two row or any two column, so the value of determinant will be also changed. What will the value of new determinant? The value of new determinant will be minus times the value of original determinant, right? So that's why we will get minus times minus, so that will become plus, right? So that's why we have plus e की power a 1 e की power 2a, The second row we have e की power b 1 e की power 2b, and the third row we have e की power c 1 e की power 2c, right? So since we have given that a, b and c are cube root of unity, it means that a plus b plus c equals to 0, right? So from here we will get that the value of e की power a plus b plus c equals to 1, right? And see that e की power a times e की power b times e की power c, we can write this as e की power a plus b plus c, and we know that the value of e की power a plus b plus c equals to 1, right? So we will get the value of determinant delta equals to 1 e की power a e की power 2a, then 1 e की power b e की power 2b, and then 1 e की power c e की power 2c, right? See that now from the second part of determinant we have interchanged the first column and second column, right? So that's why the value of determinant will negative, right? So we will get minus times determinant of 1 e की power a e की power 2a, then we will get 1 e की power b e की power 2b, and the third row we will get 1 e की power c e की power 2c, right? So from here we can say that the value of determinant equals to 0, right? Because we are taking the difference of the same number, so that's why the value of determinant equals to 0, right? So that's why the correct answer is a. Now we are going to discuss the next question. So in this question we have given that if p x की power 4 plus q x की power 3 plus r x square plus s times x plus t equals to determinant of x square plus 3x, then x minus 1 x plus 3, and the second row is x plus 1 minus 2x x minus 4, and the third row we have x minus 3 x plus 4 3x, where also we have given that p q r s and t are constant, right? So we need to find that the value of t, right? So we have given four options. So the first option is 0, the second option we have given 1, the third option we have given 2, and the last option we have given minus 1, right? So we need to find that which option is correct, right? So please try to solve, student, then we will discuss the solution. Yeah, please try to solve. Everyone please try to solve. Okay, let's see the solution. So the correct answer is a, right? So now we will see that how a will be true. So to find the value of t, we are going to put x equals to 0 in the given equation. Why? Because if you see the left hand side of the equation, we have given the polynomial that is px की power 4 plus qx cube plus rx square plus s times x plus t. So in this polynomial, what is the constant term? The constant term we have t, and all other term are involving some power of x, right? So if you want to find the value of t, so we can put x equals to 0 so that all the terms will vanish, right? And we have the value of t. So that's why to find the value of t, we are going to put x equals to 0 in the given equation, right? So when we will put x equals to 0, so from the left hand side we will only get t, right? Because all the remaining terms are involving the sum power of x, so that will become 0. So that's why from the left hand side we are getting t equals to, in the right hand side we have given the matrix, so when we'll put x equals to 0 in the first row, so we will get the element in the first row as 0 minus 1 3, right? Similarly, if we will put x equals to 0 in the second row, so we will get 1 0 minus 4. And similarly, if we will put x equals to 0 in the third row, so we will get minus 3 4 and 0, right? So when we will calculate the determinant of this matrix, so we will get minus 12 plus 12, which is equals to 0, right? So from here we can say that the value of t equals to 0, right? So now we are going to solve the next question. So in this question we have given that fx equals to the determinant of the matrix 1 x x plus 1, and the second row we have given 2x x times x minus 1, then x plus 1 times x. In the third row we have given 3x times x minus 1, x times x minus 1 times x minus 2, and then we have given x plus 1 times x minus 1, right? So we need to find that what will be the value of f50, right? And we have given four options. So the first option we have given a equals to 0. The second option we have given, the in the first option we have given that the value of f50 equals to 0, and the second option we have given that the value equals to 50, and in the third option we have given that the value is 1, and in the last option we have given that the value is minus 50, right? So we need to find that which option is correct. So please try to solve, student, then we will discuss the solution. Everyone please try. In this question you just need to use the property of determinant, right? It means that you need to take something common from the row and column, then you can find the value of determinant. Yes, and if you are able to find the value of fx, so you can easily find what is the value of f50, right? Yeah, so please try to solve. Okay, let's see the solution. So the correct answer is a, right? So now we will see that how a will be true, right? So from this determinant we are going to take common x from the second column, and we are going to take common x plus 1 from the third column, and also we are going to take x minus 1 each column from the third row, right? So after taking x as a common from the second row, x plus 1 as a common from the uh, x as a common from the second column, x plus 1 as a common from the third column, and x minus 1 is common from the third row, we will get the value of fx equals to x times x plus 1 times x minus 1, the determinant of the matrix 1 1 1 2x x minus 1 x 3x x minus 2 x, right? And we know that x plus 1 times x minus 1 will become x square minus 1. So that's why the value of fx equals to x times x square minus 1 times determinant of the matrix 1 1 1 2x x minus 1 x 3x x minus 2 x, right? So here we are going to apply the operation, that is column 3 equals to column 3 minus column 2, and column 2 equals to column 2 minus column 1. right? So after applying this operation, we will get the value of fx equals to x times x square minus 1 times determinant of the matrix 1 0 0 2x minus x plus 1 1 3x minus 2 times x plus 1 2, right? So the value of fx will become 0, right? Since here we are getting the value of fx equals to 0, so what we can say that, we can say that the value of f50 will also 0, right? So here we have calculated the value of f50, that is equals to 0. Thank you for your attention. I hope this session was useful.
Hello students, welcome to today's lecture. Yes, in today's lecture we are going to learn about work energy and power. Alright everyone? Alright. So this is our disclaimer. Let's see trend analysis of the chapter work energy and power in JEE Mains exam. So overall weightage according to last 5 years that is 2.37%. And if we talk about the yearly question distribution, so in 2024 question asked from kinetic energy. Alright, number of questions 1 and their difficulty level easy. In 2023 question asked from power and kinetic energy. Number of questions 2 and their difficulty level, one was easy and one was average. Similarly, in 2022 question asked from work energy theorem. Number of questions 1 and their difficulty level average. In 2021 question asked from collision. Number of questions 1 and their difficulty level average. In 2020 question asked from power and number of questions 1 their difficulty level average. Alright, so these topics kinetic energy, power, work energy theorem, collision are most important for the exam. Okay everyone? So in today's lecture we will discuss first work, then we will discuss work done by variable force. After that conservative and non-conservative force. Then we will learn energy, then kinetic energy. After that potential energy. After that we will discuss gravitational potential energy. Then electric potential energy. Then potential energy of a spring. After that we will discuss work energy theorem. Then law of conservation of energy. Then power, and then we will discuss collision, then elastic collision in one dimension, then elastic collision in two dimension, and then we will discuss inelastic collision in one dimension, and then coefficient of restitution, and last we will discuss about rebounding of a ball on collision with the floor. Alright, so first is work. Here question arises, what is work? Yes or no? So listen everyone, work occurs when you apply a force on a body and there is some displacement of that body in the direction of applied force. Alright, so suppose if you are pushing a heavy table and the table moves a little forward direction, then you have done work. Alright, because there is a force, there is a displacement. But if you are applying force on a wall and the wall does not move from its place, then you have not done any work. Alright, so in the absence of force, in the absence of displacement, we can say work done is equal to 0. If we talk about the SI unit, so we can say the SI unit of work is joule, and in CGS system, the unit is erg. All right. There is a relation between joule and erg. So 1 joule is equal to 10 raised to the power 7 erg. All right. So in displacing a body by a distance s, all right, and force F did work on the body. So the formula for that work done is W equal to F cos theta into S. So it will be F cos theta equal to F dot S. Alright. Here F cos theta is the component of the force that acts in the direction of displacement produced. And in vector form we can write W equal to F dot S. Alright. Where both force and displacement are vector quantity. Alright. But uh, their dot product F dot S is equal to Fs cos theta is a scalar quantity. Alright. Yes or no? Everyone, please thumbs up in the chat box. Mark your attendance. Yes. All right. So from this concept we can say W equal to Fs cos theta. SI unit of work is joule, and there is a relation between joule and Newton meter. All right. So it is equal to 1 Newton meter. So from this we can understand that if a force of 1 Newton meter is applied to an object, and due to it a displacement of 1 meters occurs, so then this is called 1 joule of work. All right. Work is a scalar quantity. All right, because it has only magnitude, and work can be of three types. First, positive work, if W equal to uh, W is greater than 0. All right. Second, negative work. All right. It means W is less than 0. And third, zero work. It means W equal to 0. All right. So we will learn each work one by one. So first we will talk about positive work. So we can say work is called positive uh, when the angle theta between the directions of F and S is either 0 or an acute angle. All right. Here we can say an acute angle is one where the angle is between 0 degrees and 90 degrees. So the angle theta will either be 0 degrees or an acute angle. So in this situation, work done on the object by the force is called positive work. All right. Next, we will learn about negative work. So negative work is defined such that when the angle between the force and displacement is either 180 degrees or an obtuse angle, meaning the angle is greater than 90 degrees but less than 180 degrees, then the work done there is called negative work. All right. So as a conclusion we can say for positive work the angle lies between 0 degree and 90 degree, and for negative work angle lies between uh, 90 degree and 180 degrees. All right, everyone. Varsha Khare, clear? Next, what about zero work? So we know the formula of work done, W equal to F dot S. So or we can say Fs cos theta. Hence, work done can be 0. There is a condition. Let's see. If first, no force being applied on the body, that is F equal to 0. So suppose uh, here F equal to 0. So you know the value of you know the formula of work done. So just put here W equal to Fs cos theta. So here F equal to 0. When you put the value, substitute the value of F, you will be get W equal to 0. Yes or no, everyone? So in that case, W equal to 0. So we can say work done can be 0 here. The second case, uh, a force acting on the body, but there should be no displacement. So imagine there is a ball, alright, and you are pushing it. You are applying a force, alright, but there is a no displacement. So in that case, also the work will be 0 because here S equal to 0. If S is equal to 0, so W equal to 0. Yes or no, everyone? So this is the second case, or we can say second scenario where work done is 0. The third uh, uh, is both. When both force and displacement are present, all right. Here force are present and displacement are present, meaning magnitude is neither magnitude of neither is 0, but the angle between them is 90 degrees. It means what? It means cos 90. All right. Cos 90 is what? Cos 90 equal to 0. So W will be 0. Yes. Clear? So if F is present, displacement is present, but angle between them is 90 degrees, due to which the work done becomes 0. Alright. So suppose an angle is moving in the horizontal direction, uh, an object is moving in the horizontal direction. Okay, object is moving in horizontal direction. If we consider the work done on it due to gravitational force, since the gravitational force acts downwards, always act vertically downward, and the displacement occurs in the horizontal direction. So what will be the angle? So we can see the angle between force and displacement will be 90 degrees. All right. If the angle between force and displacement is 90 degree, so in that case W equal to F dot S. So after resolving the dot product, you will get Fs cos theta. Just put the value of theta, that is 90 degree. You will get W equal to Fs cos 90, and cos 90 is what? 0. So we can say W equal to 0. All right. So in third scenario, or we can say in third case, when both force and displacement both are present, but the angle theta is equal to 90 degree, so we can say there is also work done is 0. All right. Clear hai? Clear everyone? All right. Now we will see work done by a variable force. So work done by the variable force, we can say in this case we need to calculate work done when the force uh, is not constant. All right, but rather a function of displacement. All right. So suppose as shown in the figure here, look at here, which is a plot of force versus displacement. All right. The force is varying with displacement in a certain manner. All right. So in this case, how can you determine the work done? Think about it. So the work done will be the area under the curve, or the area between the curve and displacement axis. All right. This means the area between curve AB, this one, and the displacement axis, this one, represents the work done. So there is a formula to calculate the work done by a variable force. All right. So work done is equal to area of A to B, B to C, or C to D, and D to A. This is a closed like a closed loop. So when we calculate the area of ABCDA, that that number is equal to amount of work done. All right. Now we will discuss conservative and non-conservative force. So here we defining conservative and non-conservative force in terms of work, and this concept is very important for the exam. A force is defined as conservative when the work done by or against it in moving a body depends only on initial and final positions, and not on path taken. All right. So for example, gravitational force, force of gravity, all right, electrostatic force, these are examples of conservative forces, or they are also called conservative fields. All right. Second, non-conservative force. So we can say a non-conservative force means that when a force acts on an object, the work done by or against that force depends on the path the object follows. All right. Then such a force is called a non-conservative force. In a conservative field, the concept of potential energy arises, but for a non-conservative force, there is a no concept of potential energy. For example, friction force, viscous force, drag force, etc. These are all non-conservative forces. So in this case, in the case of conservative force, you take an object along the path from you can take the path from initial position to final position. You will have to do work, uh, do same amount of work. All right. But if we talk about a non-conservative force, for example, if air is present and air friction is acting everywhere, then if you move the object from one place to another, the work done due to that frictional force is non-conservative, because the work done depends on the path. All right, everyone. So this is all about the conservative and non-conservative force. Okay. So this is most important concept for the exam. Next, we will understand the concept of energy. Are you ready for energy? Are you ready with energy? Okay. So energy is defined as the capacity and ability of a work of a body to do work. Energy is a scalar quantity. It means it has only magnitude, and its unit is equal to that of work, and its dimensional unit is also equal to that of work. All right. And SI unit of energy is joule. There are some other units of energy that are used. So please note down. First, uh, 1 erg is equal to 10 raised to the power minus 7 joule. This relationship is a very important. All right. So you need to remember this. Second, calorie. So 1 calorie is equal to 4.186 joules, or approximately 4.2 joules. And 1 kilocalorie is equal to 4186 joules. All right. 1 kilowatt hour is equal to 3.6 into 10 to the power of 6 joules. and 1 electron volt is equal to 1.6 into 10 raised to the power minus uh, 19 joule. All right. So these are some other units of energy that are used in different domains. For example, electron volt is used uh, when we talk about the energy of an atom. Yes or no? When the energy of the nucleus is discussed, or we can say the unit of energy mega electron volt is used. Similarly, when we talk about the heat energy, then we use calories. So these units are very important. Alright, you need to remember this. The conversion is very important. Okay. Now we will learn kinetic energy. Kinetic energy is the capacity of a body to do work by virtue of its motion. A body of mass m moving with a velocity v has a kinetic energy capital K is equal to 1 by 2 mv square. Alright. Alright. So kinetic energy of a body is always positive irrespective of the sign of velocity v, and negative kinetic energy is impossible. Alright. Here question arises, why impossible negative kinetic energy? Think about it. Dashaka, Karthik, think about it. Basically, work done is the change in kinetic energy. Alright. That's why the unit is same. So kinetic energy is always positive irrespective of the velocity sign. If v is either negative or positive, when one substitute the value of v here, v squared is obtained. Alright. Since it is a square, a positive value will always emerge and mass can never be negative. Thus kinetic energy will always remain positive. Alright. And if kinetic energy appear negative anywhere, then that process is simply not feasible. Kinetic energy can be correlated with momentum through the relationship, and that relationship is k is equal to p square divided by 2m. So in terms of p, kinetic energy p equal to under root 2m k. All right, Karthik, clear? Yes or no? Varsha, VK. All right. Okay, good, very good. So this is the kinetic energy. Here P represents the momentum, M denotes mass. If we possesses a system of particles, what will be its kinetic energy? So we have numerous particles and we need to ascertain their collective kinetic energy. Then we sum the kinetic energy of each particle. Yes or no? So in this manner, the kinetic energy of the entire system will be the aggregate of the kinetic energy of all the particles. So we can express k equal to 1 by 2 summation mi vi square. So the relationship between kinetic energy and force is such that uh, kinetic energy divided by force is equal to v into t divided by 2, where v signifies velocity and t denotes time. Okay, so you know the formula of kinetic energy, that is 1 upon mv square, and you know the formula of force, that is F equal to ma. Okay, So here just put the value of kinetic energy and force. You will be get V into T divided by 2, where V is the velocity and T is the, all right. So look at, so think, uh, so let's suppose that a ball is going upwards, all right. Ball is going upwards, but the gravity is acted always vertically downward. Acceleration of acceleration acceleration due to gravity always active vertically downward. So direction is difference. In that case we will choose sign convention, v taken as a negative, all right. So negative v. So if you uh, want to calculate kinetic energy, so negative v becomes positive v because v is a squared, all right. Next we will study about potential energy. Potential energy is the energy that is stored in a body or system due to its position or configuration. All right. For example, when you lift a ball, uh, okay, gravitational potential energy gets stored in it. Similarly, if we compress or stretch a spring, energy gets stored in it, which is called elastic potential energy. So when the spring is released, that energy is released. So potential energy is called mutual energy or energy of configuration, because this energy does not belong to a single object but rather depends on the relative position between objects in a system. Okay, so gravitational potential energy is due to the mutual position between the earth and the object. Similarly, the potential energy of a spring depends on the configuration, means arrangements of its particles. So the value of potential energy can also be defined when we choose an arbitrary reference point. Here in our case we will choose arbitrary reference point. Why? Anyone answer? Why we choose arbitrary reference point? Yes, Karthik, Varsha, VK. So the reason for this is that only the change in potential energy is physically significant and not its absolute value. So generally the reference point is taken at infinity and potential energy is assumed to be zero. Okay. So there because at infinite distance the interaction force becomes zero. So potential energy is associated with work done in this way. Potential energy U equal to minus of W is equal to minus uh, integration infinity to R F dot dr. So look at here in this formula. Here the initial limit is in infinity because U of infinity is equal to 0. So at infinity the potential energy is 0 and R is the final limit. So F dot dr is equal to W. Alright. Potential energy is a scalar quantity. It can be positive and negative. Positive and negative means that when potential energy is positive, it means the force will be repulsive. And when the potential energy is negative, it means the force will be attractive. There are different types of potential energy, such as first, gravitational potential energy, second, electric potential energy, third, spring potential energy. Alright, and we will learn each gravitational, electric, and potential energy of a spring. All right. So first, we will talk about gravitational potential energy. Okay. So this is the energy which is associated with the state of separation between two bodies when they interact through a gravitational force. So the expression for gravitational potential energy is as follows. Assume there are two bodies or two particles m1 and m2 and the distance between them is small r. So then the expression for the gravitational potential energy will be U is equal to minus g into m1 into m2 divided by small r. And this formula is very important. So if a body whose mass is small m and is lifted to a height h from the earth's surface, then the change that occurs in potential energy, that is the total change in potential energy when combining the earth and the body, is u delta u is equal to mgh divided by 1 plus h by r, and this is a general formula. So we when we take h to be much smaller than the radius of earth capital R, then in that case it becomes mgh. So approximation occurs when the object is lifted to a very small height. Potential energy formula, mgh is an approximation valid only when the height h is much smaller than the earth radius capital R. So this value mgh does not represent the absolute potential energy of the body. Rather, it quantifies the change in potential energy relative to the earth's surface. So in the case of gravitational potential energy, the zero of potential energy is taken at the ground. So here, the important point is this: all the formulas are important for your example. All right, this is the these formulas are important for your exam. Next, we will discuss about electric potential energy. So the electric potential energy of 2-point charges Q1 and Q2 separated by a distance small r in vacuum is U is equal to 1 upon 4 pi epsilon naught Q1 into Q2 divided by R. Here Q1 and Q2 are two charges and the distance between them is small r. 1 upon 4 pi epsilon naught, this one 1 upon 4 pi epsilon naught uh, is a constant whose value is 9.1 into 10 raised to the power 9 Newton meter squared per coulomb squared. Okay. Next is potential energy of a spring. So when an elastic body such as a spring is stretched or compressed, work has to be done against the elastic spring force. So the formula for this work is W equal to 1 by 2 kx square. This is the work done, meaning the energy expended in stretching or compressing the spring K. Okay. So K is the spring constant which indicates the stiffness of the spring. If K is the large, the spring is stiffer and more force will be required to move it. All right. What about X? Think about it. So X is the displacement, meaning how much the spring has been stretched or compressed from its original position. All right, everyone. Which formula? All formulas are comes from after derivation. All right. So for for solving the questions, you need to remember this. Now Elastic potential energy is U is equal to 1 by 2 kx square. This formula indicates that the work that was done gets stored in the spring as elastic potential U. Thus, work done and stored potential energy are equal to each other. Okay. So, if the spring is stretched from initial position x1 to final position x2, in that case, work done will be equal to the increment in the elastic potential energy, which is equal to 1 by 2 k into x2 square minus x1 square. All right. So this is clear. Karthik, VK, Varsha, Kundu, Muktal Kundu, Osamu, Varsha Khare, Sijanya. Clear? Okay. Let's see. Now we will understand work energy theorem. According to work energy theorem, the work done by all forces acting on a particle or object, whether conservative or non-conservative, external or internal, is equal to the change in the kinetic energy of the particle or object. Okay. So W equal to change in kinetic energy, which is equal to Kf minus Ki. So you know the unit of kinetic energy, that is joule, Karthik. And what will be the unit of work? Think about it. Yes, tell me. Yes. Okay. So W equal to change in kinetic energy, final kinetic energy minus initial kinetic energy. So we can write this as Kf is equal to Ki plus W. So this means kinetic energy after the network is done is equal to kinetic energy before the network done plus the network done. All right. So where Ki is the initial kinetic energy, Kf is the final kinetic energy. Suppose there is an object which is moving. That means it has some kinetic energy, and you did work on it, due to which its velocity will increase, due to which its kinetic energy will also increase. Okay, good. Now we will discuss about law of conservation of energy. So the law of conservation of energy states that if there is a conservative force field, then in that case the sum of kinetic energy and the potential energy always remains constant, which we call mechanical energy. So the mechanical energy E of the system is the sum of kinetic energy K and potential energy U, that is E equal to K plus U. So when the forces acting on the system are of conservative nature, then mechanical energy always remains constant. And the expression for the mechanical energy E equal to K plus U. So according to law of conservation of energy, we say that K plus U always remains constant. So the sum of change in kinetic energy delta K and the change in potential energy delta U is equal to 0. So some physical situations are such that where one or more non-conservative forces are acting on the system, but the net work done by them is zero. So then mechanical energy of the system remains constant. If net work done, sum of all work is equal to 0, so mechanical energy is equal to E, mechanical energy E equal to constant. Now we will define power. Okay, think about it, everyone. Yes, power is the quantity that measures the rate at which work is being done. The rate at which work is being done, or the rate at which energy is being transformed, is what we call power. So average power is defined as W by T, where energy can also be used in place of W. Okay, so average power equal to W upon T. The shorter, here we can say, the shorter the time taken to perform work W, the higher the power. So a person or a machine takes less time to complete a particular task, the greater the power of that person or machine. So from this relation we can say average power is equal to W upon T. So power is a scalar quantity and its SI unit is watt. So we know 1 watt is equal to 1 joule per second. This the conversion between joule per second and watt is very important for the exam. So you need to remember this. Instantaneous power. So W dW upon dt. We know the dW, that is FDS, force into displacement. So it will look like F dot ds divided by dt. So ds upon dt is what? That is V. So it will become F dot P. Some common units of power are such as, first, 1 kilowatt, which is 10 raised to the power 3 watt, and 1 megawatt, which is equal to 10 raised to the power 6 watt, and 1 HP, which is equal to 746 watt. So this is also important. Collision. Okay. So collision is a process where physical interaction occurs between two bodies. So when a physical interaction occurs between two or more bodies in which each body exerts an equal and opposite force on the other, leading to an exchange of energy and momentum, that process is called collision. So the process of energy and momentum transfer in collision. Basically, collisions is of two types. First is elastic collisions, second is inelastic collisions, and we will learn both. So if we talk about an elastic collision in one dimension, which we also call a perfect elastic collision. So in this, a total energy and the total linear momentum always remains conserved, and in this, total kinetic energy also remain conserved. Therefore, in a perfectly elastic collision, both total kinetic energy and total linear momentum of the colliding particles remains conserved. So for more understanding, look at here. The forces involved in the interactions are of a conservative nature. Okay, so there is a no change in the total kinetic energy before and after collision, meaning it remains the same. So here we have a two blocks, block A and block B, and their mass is m1, m2 respectively. Initially, their speed is u1 and u2. Before, this is the condition before collision, but after collision, uh, the mass is m2 of m1 of block A and m2 of block B, and the velocity will be v1 and v2 respectively. So in this figure, there are two bodies, as I already told you, body A and body B, whose masses are m1 and m2, and their initial velocities are u1 and u2. So these two collided with each other. After the collision, the velocity of the first one becomes v1, and the second of the second one become v2. So here m1 u1 plus m2 u2, here m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Therefore, this becomes our expression that momentum is conserved. All right. So this is our initial momentum. Okay. This is our initial momentum, and this is our final momentum. So the relative velocity of approach is equal to the relative velocity of separation. That is u1 minus u2 equal to v2 minus v1. Clear, everyone? If yes, right, thumbs up in the chat box. So v1 equal to m1 minus m2 divided by m1 plus m2 into u1 plus 2 into m2 divided by m1 plus m2 into u2. If you want to find v1, then this formula will be applied. And v2 is equal to 2 into m1 divided by m1 plus m2 into u1 plus m2 minus m1 divided by m1 plus m2 into u2. Okay. Now we will study elastic collision in two dimensions. Here in this collision, what happens? Two particles collide with each other, and after collision they move in different directions. So assume, look at here, assume uh, two particles, A and B. So initially A having mass m1, B having mass m2. Okay. So m1 and its velocity is u1, and the second particle is m2 whose velocity is u2. Okay. After the collision, both particles in different directions move in different directions. M1 particle with v1 and m2 particle with velocity v2 as shown in the figure. This scenario is clear? Yes or no? I expect answer from everyone. If yes, write in the chat box. So here linear momentum is conserved. So this linear momentum is also conserved along both independent axes such as x-axis and the y-axis. So along x-axis it will be m1 u1 plus m2 u2 is equal to m1 v1 cos theta plus m2 v2 cos phi. Here phi is the angle. Okay, what happened here? So this particle was here, it is collided. Now one particle went in this direction, okay, in this direction, and second one in other direction. That's why we get this expression. In the y direction we get expression. So because there is a no initial velocity in the y direction, therefore there will be no initial momentum. So it is written as 0. Okay. Whereas the final momentum is m1 v1 sine theta minus m2 v2 sine phi. If we talk about the kinetic energy, then it will be also conserved. So the formula is 1 by 2 m1 u1 square plus m2 1 by 2 m2 u2 square is equal to 1 by 2 m1 v1 square plus 1 by 2 m2 v2 square. This will be the result. We can solve these equations if we know the values of theta, okay, and phi. Inelastic collision in one dimension. So an inelastic collision is a type of collision in one dimension in which kinetic energy before collision and after collision is not equal. This means kinetic energy does not remain the same after and before collision. So after the collision, the system's kinetic energy decreases, but linear momentum is conserved here. Total linear momentum remains conserved. So for inelastic collision, when two particles are moving and they collide, After colliding, both stick together. This means both start moving with the same velocity, which makes it seem like they have stuck together. So in this type of situation, we calculate the common speed. So whose formula is V equal to m1 v1 divided by m1 plus m2. Here the loss of kinetic energy also needs to be calculated. Its formula is delta K is equal to m1 m2 into v1 minus v2 whole square divided by 2 into m1 plus m2. Here v2 equal to 0. So change in kinetic energy becomes delta K is equal to m1 m2 into v1 square divided by 2 into m1 plus m2. Before collision, v2 equal to 0. After collision, v equal to velocity is non-zero. Okay. Now we will learn coefficient of restitution. We just talk about purely elastic collision and purely inelastic collision. However, there are some situations between these two, and to define them, we use the coefficient of restitution. So the coefficient of restitution is the ratio of the relative velocity of separation and the relative velocity of approach. So coefficient of restitution equal to V2 minus V1 divided by U1 minus U2. The ratio obtained is called coefficient of restitution. For a perfectly elastic collision, value of E is equal to 1. And for a perfectly inelastic collision, E is equal to 0. And the value of E is between 0 and 1. Then we call it a partially elastic or partially inelastic collision. Okay. In a perfectly inelastic collision, E equal to 0, which means that V2 minus V1 equal to 0 or V2 equal to V1, which shows that after the collision, the speed of both will be same. So it can be shown that in the case of inelastic collision, the final velocity of the colliding bodies are given as follows. So it will be V1 equal to m1 minus E into m2 divided by m1 plus m2 into u1 plus 1 plus E into m2 divided by 1 m1 plus m2 into u2. This is a general expression. When we calculate for elastic, then E must be replaced by 1. And similarly, V2 will also be derived. So V2 equal to 1 plus E into m1 divided by m1 plus m2 into u1 plus m2 minus E into m1 divided by m1 plus m2 into u2. Alright. So if a particle has mass m and is moving with velocity u and it is inelastically hits another identical stationary target, then the final velocity of the projectile and the target is correlated. That is m1 equal to m2 is equal to m u2 equal to 0. This is because of masses of both are assumed to be same and the initial kinetic energy of the second particle is 0 as it is stationary. So V1 upon V2 equal to 1 minus E divided by 1 plus E. So in the case of extreme inelastic collision in which the colliding objects stick together, so before collision mass is m1, velocity v1 and second one is at rest. After collision m1 and m2 are stuck together with velocity v2. So final velocity v2 equal to m1 divided by m1 plus m2 into v1 and ratio of kinetic energy before and after collision is k even kinetic energy first divided by kinetic energy second is equal to m1 divided by m1 plus m2. So fraction of kinetic energy is lost in the collision is this one k even k even minus k e2 divided by k even is equal to m2 divided by m1 plus m2. So now we will learn rebounding of a ball on collision with the floor. So now here when a ball hits the ground and bouncing back up, the process is called rebounding. All right everyone. So after the nth rebound, the speed of ball will be Vn. So the formula Vn equal to e raised to the power n into V naught is equal to e raised to the power n into under root 2 g h naught. So height covered by the ball after the nth rebound. So hn is equal to e raised to the power 2n into h naught. So after dropping, it will bounce back if the ball jumps many times or hits many times. Okay, then gradually its height will decreases and finally the ball will stop. Then so total distance covered will be h is equal to h naught plus 2 h1 plus 2 h2 into h2 plus 2 into h3 plus so on is equal to h naught into 1 plus e square divided by 1 minus e square. So the formula will be this one. All right. Now we will calculate the total time the ball will take until it stops bouncing. So for the first bounce, then for the second bounce, then for the third bounce, similarly there will be a fourth bounce as well. And when the ball finally stops, we need to find the total time until then. So t equal to t naught plus t1 plus t2 plus t3. So it will be t is equal to under root 2 h naught divided by g plus 2 into under root 2 h1 divided by g plus 2 into under root 2 h2 divided by g plus so on. So solving this, you will be get t equal to under root 2 h naught divided by g into 1 plus e divided by 1 minus e. Alright. So let's see what we have learned. First, work. Energy transferred when a force causes displacement, calculated as a force times displacement. Then work done by a variable force. Then conservative and non-conservative force. Then energy. Then kinetic energy. Then potential energy. Then gravitational potential energy P equal to mgh. Then electric potential energy. Then potential energy of a spring 1 by 2 kx square. Then work energy theorem, principle stating that the work done on an object equals to its change in kinetic energy. Then law of conservation of energy. Then power. Then collision. Then elastic collision in one dimension. Then elastic collision in two dimension. Then inelastic collision in one dimension. Then coefficient of restitution. And last, rebounding of a ball on a collision with the floor. All right, everyone. Yes or no? Yes, everyone. Clear? Daksh, Karthik, VK, Varsha. Thank you for your attention. Now we will solve DPP questions. So are you ready for DPP? Yes or no? Write in the chat box. DPP. So uh, are you ready? Yes or no? Okay. Which color is your favorite? Tell me. Blue, green, green. Green is okay. Okay. So first question, the kinetic energy of an object is given by k is equal to 1 by 2 mv square. Okay. The if the velocity of the object is doubled, okay, suppose the velocity prime is equal to 2v doubled, okay, initial uh, velocity is equal to v, okay, then uh, new velocity become equal to 2v. So if the velocity is doubled, its kinetic energy becomes what? So here you have to find out the kinetic energy. Yes, please solve. You have some time. Everyone, please solve. Varsha, VK, Sa, Karthik, please solve. You know the formula of kinetic energy? Yes or no? Kinetic energy is equal to 1 by 2 mv square. Okay. So this is the formula. So suppose the initial kinetic energy is equal to 1 by 2 m vi square. Yes or no? So just put the value ki equal to this 1 by 2 m v square. Okay. Now final kinetic energy is what? Is doubled. So kf is equal to kinetic energy final kef. Okay. So that is 1 by 2 m final velocity is to be, okay, square. So it will be 1 by 2 m 4 v square. Yes or no? So we know the kinetic energy formula, that is equal to 1 by 2 m v square into 4, this one. So we know this, that is equal to 4 into this one. This one is what? Kinetic energy initial. Yes or no, everyone? This one. Okay. So which one is correct? So we can say 4 times. So save and next. Second one. So question is, a bullet of mass 50 gram fired with a speed 200 meter per second. Its kinetic energy is what? Yes, please answer. You know the formula of kinetic energy? Ke is equal to 1 by 2 mv square. So here mass is given in grams, so you need to convert in kilograms. So 50 divided by 100, so it will be what? 0.5 kg. So it will be 1 by 2 into 0.5 into v square, that is 200 square. All right, please solve. Which one is correct? So 1 by 2 into, we can write this like 1 5 by 100, 50 by 100. All right. Yes or no? This one is 1000. 1 kg, 1. So 50 by this one. So when we solving this, you will be get 0.05. All right. So 0.05 and into 200 two times. So which one is correct? Yes. Tell me. So we choose one. Suppose the answer will be 2000 joule. Okay. Save it next. Answer will be this one. So save it next. Next one is a raindrop of mass 3.5 into 10 raised to the power minus 5 kg falls at terminal speed 9 meter per second. Its kinetic energy is approximately what? So again here you have to find out the kinetic energy. So use the formula Ke is equal to 1 by 2 mv square. Please solve this question. So which one is correct? Yes. Please solve. Next. When calculating work done by a variable force, which mathematical approach is used? First, summation of discrete forces. Second, define integral of force over displacement. Third, differentiation of force with respect to displacement. And last, average force multiplied by total displacement. So which one is the correct option? Yes, think about it. So choose anyone. And next one. A bullet loses 90% of its kinetic energy after passing through a plywood of its initial speed is 200 meter per second. Then the final speed is approximately what? Yes, please solve. Which one is correct? Karthik, so choose any question. Sixth one. A force F is equal to 3x square Newton acts on an object, displacing it from x equal to 0 to x is equal to 2. What is the work done? So here you have to find out the work done. So you know the formula of work done, W is equal to F dx. Yes or no? Integration. So use this concept and please solve this question. So I think answer will be this one. Next one. So a spring with spring constant K equal to 100 Newton per meter is compressed by 0.1 meter. What is the work done in the compressing the spring? So you know the formula to calculate the work done by a spring. W equal to what? 1 by 2 kx square, or W equal to integration f dx. So using these two formula, please solve this question. Okay. So let's see next question. What is the dimensional formula of potential energy? Think about it. This is a very simple question. Next. Work done by a force is a vector scalar, always constant, 0. Yes. Answer this. Everyone. This is a very simple scalar quantity. Last one. If the displacement x of a particle moving in one dimension under the action of a constant force is related to time t by the tension t by the equation t equal to under root x plus 3, where x is in meters and t in seconds, the work done by the force in the first 6 seconds is what? Please solve this question. You know the formula, dw equal to integration f ds. Please solve using this concept. Okay. So we know w equal to f dot delta x. So just put the value and solve it. So which one is correct? So this one, these questions are helping your preparation and boost your confidence. So please try everyone, all right, and every day. So save and submit. So these are the solutions. First, second, third, fourth, fifth, sixth, seven, eight, nine, 10. All right. Yes or no? Any doubt? If you have any doubt, please ask. Karthik, Varsha, VK. All right. No doubt. These are the solutions. Everyone, any doubt? Yes or no? Okay. Thank you for your attention. Thank you.